Beneath the turquoise waters south of Java, something is brewing. In 2004, a 9.1 earthquake triggered a tsunami that erased entire cities. Over 230,000 lives lost in a single morning. But what if we told you that wasn't the worst it could get? Because deep beneath Java, an area with no known record of rupture, scientists have found a fault line that may be more dangerous than the one that caused the 2004 disaster. It's still locked, still loading, and when it breaks, the tsunami could be twice as fast and even higher. This is the story of the Sunda Megathrust and the silent segment that might already be counting down. The sleeping giant beneath Indonesia. Stretching over 5,500 kilometers from Myanmar to the southern edge of Indonesia, the Sunda Megathrust is one of Earth's most dangerous fault systems. But unlike the San Andreas, which moves side to side, the Sunda fault shoves vertically. That's the dangerous kind, because when one tectonic plate plunges beneath another, the seafloor lifts, instantly displacing water and triggering massive tsunamis. That's exactly what happened in 2004, and yet it was only a partial break. Vast sections of the fault, especially beneath Java, didn't move at all, and that's the problem. Those locked sections are under strain, like a rubber band pulled tight, and every year they don't move, the eventual rupture gets worse. What 2004 didn't break. December 26, 2004. A calm morning shattered by one of the most powerful earthquakes ever recorded. A segment of the Sunda Megathrust ruptured under the Indian Ocean, releasing energy equivalent to 550 million Hiroshima bombs. The seafloor lifted by 20 meters. The tsunami came minutes later, striking Indonesia, Sri Lanka, India, and Thailand. The death toll? 230,000. But here's what most don't know. That was only one part of the Sunda fault. The Java segment? Silent, unbroken, waiting. What's happening now? In 2025, satellite data revealed something alarming. The Java section of the megathrust is deforming, bending, without releasing any quakes. That means the pressure is building, and a recent simulation showed this segment could unleash a magnitude 9.0 earthquake. Worse, the uplift could generate a tsunami up to 20 meters high. That wave could strike Java's southern coast in under 20 minutes. Cities like Yogyakarta, Cilacap, Denpasar, home to millions, would be directly in its path, and most of them aren't ready. The ocean hides what's really going on. Deep beneath the seafloor, the Indo-Australian plate is diving under the Eurasian plate, creating immense pressure that is largely invisible until it's not. What scientists are now seeing is eerily similar to the buildup before the 2004 quake. Deformation in the crust, microquakes, subtle ground shifts. This is how the Earth whispers its warnings. Who's in the crosshairs? Let's talk specifics. Southern Java is home to cities and towns built just meters above sea level. In many places, people live only 2 to 5 meters above the ocean. That's barely enough time to run, let alone escape. Yogyakarta, a cultural hub and home to millions, sits near the potential impact zone. Cilacap, an industrial port, could be hit directly. And Bali, one of the most visited islands in the world, has tourist zones right along the coastline. Kuta Beach, Denpasar, Seminyak, thousands of tourists and locals could have just minutes to act. And inland, cities like Bandung and Jakarta might not face waves, but they'll be rocked by intense shaking, power outages, collapsed buildings, fires, landslides in the mountainous regions. The damage wouldn't stop at the shore. The science of prediction. For decades, scientists could only estimate risk, but now we're entering a new era of earthquake forecasting. AI-powered systems now monitor over 100 parameters in real time. Strain rates, microseismicity, GPS drift. These models are learning from past quakes, detecting patterns that human eyes might miss. One model from 2024 focused on the Sunda Strait and projected a significant rupture window as early as 2026. Another, broader in scope, estimates that a multi-segment cascading event could occur between 2030 and 2032. These aren't just guesses, they're based on physical data, how fast the plates are moving, how much strain is building, and how long the fault has been silent. And silence isn't peace, it's pressure. The Cascading Threat. In 2004, the rupture spread 1,300 kilometers. What started near Sumatra didn't stop there. It continued to break segment after segment in a chain reaction. Scientists call this a cascading rupture. One fault unlocks, triggers the next, And right now, there's fear that Java, Sumatra, and even the Bali Trench could go the same way. A full segment rupture could generate a quake above magnitude 9.2. Tsunamis could strike not just Indonesia, but Malaysia, Thailand, the Maldives, Australia, and even the East African coast. Entire nations could be impacted by an event that begins silently beneath the sea. What's been done and what hasn't? After 2004, Indonesia stepped up. Billions were invested in early warning systems, sensors, GPS buoys, and education programs. Schools began holding tsunami drills. Emergency maps were drawn, sirens installed. Today, a network of seafloor pressure gauges and satellite-linked GPS stations monitor the fault in real time. Alerts are broadcast via mobile towers within seconds of detection. But here's the hard truth. Technology can only go so far. Even with the best warning system, if a tsunami hits in under 20 minutes, and you're 5 minutes from shore, there's little time to react. Some towns have no vertical evacuation centers. Roads are narrow. Infrastructure is aging, and in rural areas, many people still lack basic awareness of what to do when the sirens sound, if they sound at all. And worse, thick sediment blankets the Java Trench. This sediment can muffle seismic signals, delay detection, and make it harder for sensors to identify early rupture signs. So, in a critical moment, the warning might come too late. The Mystery of Mentawai. There's one segment of the Sunda Megathrust that's especially strange. The Mentawai Gap, off the coast of Sumatra, hasn't ruptured in over 200 years. It's not accumulating strain the way other segments are. Some scientists believe it's behaving differently, anomalously. Could it be a seismic buffer or a hidden trigger? Some models suggest that if the Mentawai Gap breaks, it could unleash a massive quake and initiate a cascading failure that involves Java and Bali. Others believe the opposite, that it could absorb stress and delay catastrophe. Either way, it's unpredictable. And unpredictability is what keeps seismologists up at night. The bigger picture. This isn't just about Java or Indonesia. The Sunda Megathrust is part of the Pacific Ring of Fire, a region responsible for over 90% of the world's earthquakes. What happens here ripples outward, economically, geopolitically, environmentally. If the Sunda Fault breaks, ports shut down, trade routes freeze, oil, gas, and shipping lanes go dark. Humanitarian crises erupt. The global system feels the shock. It's not fear-mongering, it's math, physics, and history. So what do we do? First, awareness. Knowing the fault is there is the first step. Second, preparation. Community drills, faster alert systems, better infrastructure. And finally, understanding. The Earth doesn't quake without reason. The signals are there. We just have to listen. The Sunda Megathrust holds more energy than almost any fault system on Earth. Java's silent segment could rupture in years or months. And there's one underwater anomaly that may hold the key. In our next episode, we dive deeper into the Mentawai mystery, what it is, why it's different, and how it might decide the fate of Southeast Asia. Subscribe to stay ahead. Drop a comment with your theory. And if this changed how you see the ground beneath your feet, hit like. Because when it comes to megaquakes, it's never a matter of if, only when.